welcome back to my number sense series. In this video, we're going to be doing the fourth video in our estimation mini-series on exponents. So exponents are a little bit difficult because exponents grow really quickly, right? That's why people say something grows exponentially, even if it actually doesn't. They just use it to mean that it grows really quickly. So with exponents, we have to make sure that a little rounding we do does not blow up in the future, right? When we take that exponent, it turns out that imperfections tend to become extremely magnified in our result. For example, consider our first question here, 31 to the power of 4, right? Now, according to the estimation rules, any answer within 5% of the correct answer is acceptable. So if the answer to an estimation question were 31, then it would be perfectly acceptable to write 30 instead. However, let's look at what happens when we raise both of these to the power of 4. If I wanted to kind of shortcut this question and say this is approximately equal to 30 to the power of 4, here's what would happen. Well, this would turn into 810000. Well, this one would turn into 923521. And here you can see this is a massive discrepancy, okay? This is way beyond the 5% rule, and so we can definitely not round like this, even if it might seem like it before we exponentiate. So with exponents, we have to be a bit more careful. It's going to require a little bit more computation, but as long as we're clever with it, it won't be too bad. So how could we do something like 31 to the power of 4? Well, with this question, we're going to have to kind of split it up. Instead of looking at 31 to the power of 4 as 31 times 31 times 31 times 31, we can look at it as 31 squared and then squared again. And so we can hopefully know what 31 squared is, because this is something that you should memorize. 31 squared is 961. And then we can round 961 squared. First of all, because 961 is a bigger number. So if we were to round 961 by 1, it would have less of an effect on the final answer than it would if we rounded 31 by 1. Also, here we have a squared instead of a to the power of 4, so any imperfections, any rounding we make is going to not be magnified as much. It's still going to be magnified by roughly a power of 2, but that's much better than what's going to happen if we do it to the power of 4. So 961 squared, of course, we still don't want to compute that, but we are allowed to round a little bit here. So what we can do is we can round it to 960 squared. Now 960 squared, this is basically saying what's 96 squared times 100. And we know how to do 96 squared from our multiplying 90s trick. So what we're going to do, in case any of you forgot, here's a little refresher. 96 and 96, how much do they differ from 100 by? I'm going to keep those two numbers in my head. They differ by 4 and 4 because they are the same number. 4 and 4. So my first two digits are going to be 100 minus 4, which is 92. And my next two digits are going to be 4 times 4, which is 16. And so add 0. And that is a pretty accurate final answer. You can see it's only off by around 2,000, as opposed to this, which is off by 113,000. Much better. So this is kind of the idea that we're going to be using with exponents. Don't round immediately, but try to round intermediately and see if that can simplify the calculations. And of course, knowing your squares is going to help a ton here. So our next question, 32 cubed. Since 3 is a prime number, we're not going to be able to do this thing exactly, but we can kind of simplify it anyways, because 32 cubed, that's 32 times 32 times 32, right? So as we're going to compute this, we'll just do one of these first and then multiply by 32 again. 32 squared, you should know, is 1,024. 1,024 times 32. And now here, we should be going, wow, that's a golden opportunity, because 1,024, that is super close to 1,000. In fact, it's only 2.4% off from 1,000. So we know that we're going to be able to round 1,024 to 1,000, and then since we can multiply 1,000 exactly by 32, our error is not going to be, super off, right? It's only going to be a 2% error. So if we just round this to 1,000, we can write 32000. And in fact, this is off from the actual answer by only about 770. So, we are pretty close here. Again, only a bit more than a 2% error, which is pretty good. So our next question, 45 cubed. Now, I don't expect you guys to have numbers above necessarily like 40 squared memorized, but 45 is a number that we are able to square in our heads easily, right? 45, what's 45 squared? Well, 45 squared we know is 2025 from our trick for squaring numbers that end in 5. So we can write 45 cubed equals 45 times 45 times 45, and this is equal to 2025 times 45. Now, once again, 2025 is close enough to 2000 that we can just round it to 2000, and we're only going to have like a 1% error on our final answer, which is really nice. So if we say this is just 2000, then we can write our final answer to be just 90000. And once again, this is honestly like pretty close to the final answer, like not far off at all. So 55 to the power 4, 4 is a composite number, right? 4 is 2 times 2, so we're going to be able to do the same thing that we did over here. So that's what we're going to do. We're going to write 55 to the power 4 as 55 squared squared. It's 55 squared and then squared. And we're going to have to compute 55 squared directly, but luckily this is something we know how to do because 55 ends in 5, so we can use our trick. It's going to be 5 times 6 is 30. Add a 25 at the end, that's 3025 squared. And now once again, we see that this is really nice. And if you think it's a coincidence that all our answers are super nice so far, it kind of is, but it's also kind of not because number sense does choose these nice numbers on purpose usually to make it easier for you. So 3025 squared, right? We can round this to 3000 without any fear because 25, if you're thinking about this in your head, 25 is like 0.8% of 3000. So even if we square it in the end, our error is not going to be huge at all, right? Very much under 5%. So it's 3000 squared basically, which is just, 9 million. Very nice. And our last example, 21 to the power 4, we're going to introduce a little bit of a new technique here, but we are going to start the same way. So 21 to the power 4 is 21 squared and then squared. Now, hopefully we know what 21 squared is. It's going to be 441. So it's going to be 441 squared. Now, 441 doesn't round to anything that is particularly nice. Something you could do here is actually round to 450. However, that's about a 2% error. And when you square that, it could become larger. So I think mathematically it would technically be fine if you rounded it to 450, but I would like to introduce a new technique here. And I would not like to take that risk. Around a 4% error, that kind of scares me a little bit. So I'm going to do a bit of a new technique here. 441 squared. First of all, I am going to round this to 440. This is a very safe round, of course, because it's, 1 versus 400 something, pretty much no error. 440 squared. Okay, how can we do 440 squared? Well, 44 squared is not a number that people usually memorize. So we're going to have to do something a little bit creative here. Remember that thing in multiplication where we said if we raise one number and we lower one number, sometimes the errors might cancel out? That's what we're going to do here. 440 squared is, 440 times 440. So, so if we can lower one of these numbers and raise one of these numbers, in a kind of equal fashion, then theoretically the errors should mostly cancel out. And, mostly is good enough for estimation. So 440 and 440, this is, pretty close to 400. So we can lower one of these to 400, and then since we're lowering by 40, we're going to raise by 40. So we lower this to 400, and we raise the other one to 480. And now if you're thinking, to change a number by 40 when it's only in the 400s, that's a little bit risky, right? But later I will mathematically prove to you that, in fact, it's not actually risky in the slightest. 400 times 480, this is a much easier computation to do. It's 4 times 48 with 3 zeros at the end. So it's 192000. And now if you're curious as to why I'm able to do this, what we're essentially doing is invoking the difference of squares. 400 times 480, that's going to be 440 minus 40 times 440 plus 40, right? And now this, according to difference of squares, is going to evaluate to 440 squared minus 40 squared. So essentially this 40 squared is going to be our error term. However, note that 40 squared, so 40 over 440, that's 1 over 11, right? But when you square that, it becomes 1 over 121. In other words, 1 over 121 is basically our difference, and that is less than 1%, which is very much in bounds for estimation. If that didn't make too much sense, don't worry, but essentially just know that our technique doing this, raising and lowering by the equal amount, is basically not going to give you any risk unless you do it by like way too much. But most of the time, you should be able to assess when it gives you a multiplication that is like decently fine to do, and just perform that. So yeah, that's going to be exponents. You can see that it's a little bit harder than multiplication 1, for example, because exponents grow faster, and so we have to be more careful with our error. But you can also see that if we know our squares, if we have a little bit of creativity, we can simplify these calculations by so much. It's really just according to how we think. So keep your risk assessment skills up and remember your squares, and you should be completely fine. So yeah, that's it for today, and thank you guys for watching.